Hey guys, welcome to the next alkyne video. So this one is going to be all about synthesis using alkynes. Now just a warning, some of the synthesis in this video will be fairly cumulative, using pretty much everything you guys have seen so far in Orgo 1 because this is the end of the semester, okay? So if you want to maybe get practicing with your stuff before you watch this video, get used to a lot of the more of the reagents, feel free to do so. Otherwise, let's get started. So the first synthesis we're going to go through is not too complicated. It's going to be one of the simpler ones. Let's make this bigger a little bit. So we're going to have this compound here. So we're going to get this compound. All right, we want to synthesize this compound from 4 carbons or less. All right. So let's see what we have here. We have this carbon chain with 2 bromines on carbons next to each other. Same stereochemistry. Now, we know how to get 2 bromines on carbons next to each other. This would be Br2. The only thing is, this is an anti-addition. So if we had our double bond looking like this, let me just make it better. If we had this reacting with Br2, we should get this compound. 1 dashed, 1 wedged. So, that's a bit of a dilemma. What can we do to do to fix this? Well, what you can do is, let's say I rotated one of these bonds, right? So I'm going to rotate this carbon right here. So let's keep the top one the same. And now you're going to get this. All right, so you can see here that dash BR is now gone to wedged because we did a 180-degree turn. If you're confused on how I did the bond rotation, please go back to the next video. I talked about this pencil trick using your eraser, something like that. All right, so now that looks anti. So if we did Br2 to get that as the product, then our double bond should go right there. So let's draw what that's going to look like. So that would work. Oh, let's write Br2. So that would work. So what you should do, going backwards, is we're going to write Br2. And rather than drawing that trans product, we're going to draw the cis product. And I'm going to just rotate the other carbon to make it a little bit neater. We're going to get this alkene. Okay? Because that will give us a trans. And all they did is they just rotated the bond in the product. All right? That's fair game. So now we have this alkene and we want to go backwards, right? So we know how we can create double bonds, right? We know how we can create cis double bonds selectively. That's going to be H2 over Linoir. So let's count our carbons first. 1, 2, 3, 4, 5, 6. 6 carbons. And our triple bond is going to be from carbon 3 to 4 now. So let's draw this. And count our carbons to make sure that we got everything right. 1, 2, 3, 4, 5, 6. All right, that's good. So now we have this triple bond. What's the next step? Well, we know how to extend alkynes. We learned that if you have a terminal alkyne, right? Something like, let's say like this, right? And here's that H that's part of it. And we use NaNH2. We deprotonate that guy. Gets a negative charge. And he can do then an SN2 on some sort of primary leaving group to extend it. So we're going to do the reverse of that SN2. So all you do, pick a side of your triple bond and kind of cut between that. I'm going to pick carbons 2 and 3. I'm going to cut that bond. And so what's going to happen is draw carbon 3 to 4, which is your triple bond right here. and the rest of it. And then let's number to keep it all consistent. 3, 4, 5, 6. He's going to have a negative charge. Plus, and now let's bring this a little bit back here. Plus, or actually just even an arrow is fine, like this. And now we have carbon 1 and 2 right here. 1, 2. And the bromine should be off carbon 2. Right? And so that would have performed an SN2 attack and gave us this product right here. Alright, and then the last step that you should just do is, because we already have 4 carbons, but NaNH2 to deprotonate this guy and show him in the neutral form. And now we just have this. Alright? And so that's how you do the synthesis. Hopefully you guys didn't find that too bad. Alright, so a lot of alkynes is just a little bit kind of like puzzle solving. So hopefully you guys didn't find that one too terrible. Now let's go on to a little bit of a harder one. This is going to be using more reactions you guys have learned previously. Alright, so now let's try this one. Alright, so you'll notice a lot of these alkyne synthesis use a little bit of stereochemistry to kind of point you in the direction. And so this is similar to what we did before. Right? And again, we're going to do 4 carbons or less. Let's just write that down. And so you can see that we have 2 BRs, same stereochemistry, adjacent carbons. So this looks like it would have been a syn addition, but we know that BR2 addition is anti. So that means we probably have a bond rotation somewhere. So let's draw what this is going to look like backwards. And you notice I'm going a little bit faster in this part because you guys have seen this. This first part is very similar to the previous problem. So now we have this. Again, a cis double bond. Going backwards, we know exactly how to make that. H2 Lenoir. And so count the carbons. 1, 2, 3, 4, 5, 6, 7, and 8. And so your triple bond is going to be between carbon 3 and 4. One, 2, 3, 4, 5, 6, 7, 8. And there's that methyl. So 6, 7, 8. Now you may be wondering, okay, well, why would you use H2 Lenoir? Maybe you know stuff that works backwards can give you double bonds, like an elimination reaction, right? So why can't I just maybe do something like OH minus and put a Br on carbon 3 or 4, right? Well, first of all, if you put the Br on 3 or 4, they're equally substituted. So you may not get the double bond on 3 or 4, you could get it on carbon 5, between carbon 4 and 5, or 2 and 3 if you put it on carbon 3. And also you can't guarantee that it will be a cis double bond because it probably would have been trans, right? Just because that way it's more stable. So this is why you'd want to go with the H2 Lenoir. And so now we're going to have this compound. Now again, you kind of want to do the alkyne cut, sort of the backwards of the extension. And so to make this easier, you want to make your synthesis as quick as possible to make it easier on yourself. I'm going to cut as many carbons as possible and cut between 4 and 5. This way. So let's draw your alkyne. That was really bad. So here's carbon 1, 2, 3, and 4. Now remember, this is going to have a negative charge. And we're going to have the rest of that compound. So we're going to have the carbons here. So that's going to be 5, 6, 7, 8. And on carbon 5, we're going to have our bromine. Right? Now, so this compound here is 4 carbons or less. That's great. But this compound here is actually 5 carbons. 5, 6, 7, 8, that's 4, plus this methyl. We cannot stop at that. all of your reagents must be 4 carbons or less. So what I'm just going to do, take this guy, move him down, and I'm going to just write this on top of the arrow. Okay, and so now we just want to finish off this guy over here using the stuff that you guys already know in synthesis. So it's not going to be that bad. So we're going to do PBr3, right? Because it's a primary bromine. And we're going to get an OH there. Now you could have also used HBr, right? HBr works on this because we're going to just, if you use HBr, you'd protonate this guy. And he's not going to leave on his own because you'd get a primary carbocation. So the Br minus you generate is just going to attack that carbon and kick this guy out. So you'd still get that same compound and able to avoid shifting at the same time. You could use PBr3 or HBr. It's all fine. And so now we have this OH. Now you just want to do a cut. Here's the carbon with the OH. We're going to cut this bond here. All right. And so you can see that this carbon with the OH has 2 hydrogens off of it. So I'm going to go H, carbonyl H as step 1. Step 2, H2O. Okay? And then that means let's just count the carbons quickly. 1, 2, 3, 4. Right? And we use this carbon over here in red was part of the carbonyl. So we have this 4 carbon compound, right? It looks like this. 1, 2, 3, 4. And that means off carbon 1 we had the lithium, Li. All right. And so that would be the end of the synthesis because that's 4 carbons or less. And so you could be done with that synthesis right then and there. All right. So you see, not too bad, hopefully at least. So it's going to be mainly the initial part that's a little bit tricky, right? Figuring stuff out that could be with stereochemistry, wonky stuff like that. Okay? So again, hopefully not too bad for you guys. So I will see you guys in the next video where I'll probably do a little bit more synthesis. All right?